Hello, my name is Amin, and our project title is Automatic Irrigation System. Other members are Mr. David and Mr. Metin. Our unit coordinator is Dr. Priti. Today we talk about the background and objectives of this project. After that, equipment used, block diagram, working process, constraint, project model, Gantt chart, and finally we talk about the conclusion. This project is to develop automatic irrigation system with PIC 18F4321, temperature sensor, light sensor, soil moisture sensor, and the mobile for control the pump. As you can see, in the past, the farmers used the man for irrigate the farm, and after that they used the manual pump, which is just use the electricity and pump the water. They cannot control that, and there is a lot of water waste in this system. Now they can use the modern system of irrigation. The objectives for this project is less man work, save water, prepare irrigation, and remote control of the irrigation. My friend David continues this presentation.
So, listed below are the equipment we use to execute this project. We use an LM35 temperature sensor, a soil moisture sensor, a light sensor. These three sensors gives analog output of 0 to 5 voltage. We also use a 12 volt water pump, water container and connecting pipes, PIC 18F4321. This is the engine of the whole project because this controls the project. We use connection wires, jumpers, and 12 volt DC battery. Yes, no? This is the block diagram of our project, and from this block diagram you can see the processes that the project goes through before it gives the actual output. So in this microcontroller we connected the temperature sensors, the light sensor, and the soil moisture sensor in the analog input of the microcontroller, where it sends the information. When the sensor sends the information, it gives an analog input of 0 to 5 to the microcontroller, which use this information, this input, to execute a function, which is to on this power water pump and then irrigate the farm. So since we cannot power our water pump directly from the microcontroller because it's a 12 volts DC water pump, we actually develop our own circuit using a relay and a transistor and a 12 volt battery power to power this water pump. So when the microcontroller gets information from either of these sensors, it then gives this information to the water pump and say come on, and this water pump then takes water from the water container, as you can see from this diagram, to then take it to the farm to irrigate the farm. So this is our GSM module that we actually plan to work on, but we haven't been able to complete that process. So this is the technical part of our project. Starting with the temperature sensor, which is LM35, what it does is gives analog output of 0 to 5, and through series of codes we have developed and input in our microcontroller, our microcontroller now understands that when it gets this analog input from our sensor, it should first of all convert it to millivolts. And when it does that, it should understand that 10 millivolts is equals to 1 degree Celsius. In our project, we have set 37 Celsius as the trigger point, trigger Celsius, the trigger temperature, to actually set information to the pump. So when the temperature gets to 37, then the microcontroller should send an information to our DC pump and say come on and irrigate the farm. So our sensors, we use a variable which is called dark in our program. So when our light sensor sends 0, which is darkness, it should compare it with what information is getting from the variable we use, which is dark. So if the information it's getting is 0, which is darkness, and it compares with is dark and it gives 0, then it should know that it's actually darkness. But when there is a change and it compares with the variable we declare, which is dark, and it says, okay, it's dark is now 1, and you are now getting 500 millivolts, then it's morning, so it's time to irrigate the farm. So it has to send information to the microcontroller. We now use this information to energize our DC pump. So the final sensor is the soil moisture sensor, which works as a deactivator. We set it to work as a deactivator. So what it does is that when there is no moisture in the soil, it has an output of 0, an active low. But when it sends moisture from the soil, it gives an active high, which is 500 millivolts. So when our farm when our pump have irrigated the farm enough and there is now moisture in the farm, which the plants can use to stay moisturized for the day, then our soil moisture sensor should get that information and then pass an active high to the microcontroller. We receive this information and then stop our pump from working. It will go off. Next slide. My friend Nick will continue from here.
So actually we got one constraint in our project. When we are doing this project, we bought GSM SIM 900 module from India, and actually it's not working as an Australian standard. So we are unable to use the GSM module in our project, but we try to use a serial port from through which we can give an input to microcontroller. If we type on, then it will turn on, the microcontroller sense it and turn on the pump, and if we will write off, then it will turn off the pump. Next slide please. So this is the real picture of our project model. As you can see, there are 3 sensors. One is light sensor, one is temperature sensor, and soil moisture sensor. And here is a container in which you can find a water pump and water. And this is a microcontroller PIC 18F4321. Next slide please. So this is a Gantt chart which shows you, which illustrates you the activities we have done throughout this semester. So we just started working on our project from since mid-March 2018, and we are hopefully finish this one in May ending and starting of June. Next slide please. Yes. To be conclude, through this project we can save water, as we are just gonna turn on the pump whenever it requires only. We can reduce the manpower as it is fully automated project. We can actually, it's also flexible as well, because we can operate it from a remote location, so it is really flexible to use. And through this project we can get very good agricultural product, as we are just gonna irrigate it whenever the field requires water, and it's through this process we are getting very good product, and we can save water as well. So it's finishing our presentation. Thank you.